I am Dr. Prabjot Kaur. So in the last video we discussed about one-dimensional array, and in this video we are going to discuss two-dimensional arrays. So first of all, I would like to tell you that why there is a use of two-dimensional array, why we are using two-dimensional array. Basically the use is similar to single-dimensional array, which we already discussed in the last video. So let's say we have a data which is in the form of a table, like we have similar to the characteristics of a table. We have our rows which are corresponding to the number of students in a class, name of the students row wise, and in the column we have the marks which have attained by the students in various subjects. So we have a table form data which we have entered into the Excel form, and now we want to do calculations on that data. We want to feed that data, we want to use that data into a program. Now how we can store such kind of table form data in programming? So here is the use of two-dimensional or multi-dimensional array, because in this case we have two dimensions, one is the column, another one is the row. So two-dimensional array is the most commonly used multi-dimensional array. Now, so how will we declare two-dimensional array? So if we see, first of all, similar to the single-dimensional array, we have to first specify the data type, then we have to specify name of the array. Here, to tell it is a two-dimensional array, we will have two subscripts. The first subscript will tell us the number of rows, and second subscript will tell us the number of columns. For example, in this particular statement declaration, we have a matrix array, two-dimensional array with the name matrix, and we have 3 rows and 4 columns. That means that in this two-dimensional array we can store a maximum of 12 elements. So if we have to display it in a table form, this will be the first row, the second row, and the third row. But in C programming, the first subscript, index or first subscript will be 0, that is number -1. That means first row will designate as row 0 and first column will be denote as column 0. So we have 4 columns and 3 rows. In the memory we can store this data in this form. So first 4 element will specify the first row, next 4 element will specify the next second row, and the next 4 elements specify the third row. Now to access the array elements of, let's say in the previous slide we have an array of 12 elements. So first element will be at the 0th row and 0th column. That will be the first row, first column. And to this particular element we will access the element which is at the 3rd row and 4th column, that is last row and last column. If we write just the name of the two-dimensional array, that will be equivalent to the first element. We will specify the element at first row and first column. And if we are only specifying the first subscript, we are not specifying here the second, so by default we'll take it as the first row, address of the first row, and will specify the first element of the first row. For example, here we are in this particular slide, we are initializing the array element. We have an array with the name X, and wherein we have 4 rows and 4 columns. That means we have total of 16 elements, right? So this specify the first row. It will be the 0 row and 0 column. This will be the 0th row and the first column, 0th row and the second column, and 0th row and the third column. Similarly, we have first row 0th element, we have first row first column we have first row, second column we have first row and third column. This will be the third row and this will be the fourth row. We can also specify two-dimensional array by not writing the size of array during the initialization, because by default it will take this row as the 0th row, first row, second row and the third row. That means a total of 4 rows and 4 columns. We can also initialize this two-dimensional matrix with the help of a loop. Here, to access two-dimensional array, we need 2 for loops. This first for loop will access the row part of the matrix and the second will specify the column part. So what we are doing in this case, we are assigning the ith value to a particular ij element of a matrix. That means when we are accessing this loop, the I value will be 0 and for loop j will vary from 0, 1, 2, 3. That means 0th, first of all, I or j will be equal to 0, 0. That means the first element will be 0. Right? Again, as we are assigning the ith value, so for the first row, I will be 0. So for first row and all the columns, this I value will be 0. Next time I will be 1. So for the second whole row, I will be equal to 1. And for the third one, it will be equal to 2. So similarly, if we can change the statement and we can assign j value to the same array, that means that for the first row, our j value is varying from 0, 1, 2, 3. Similarly, if we are assigning j value to those locations, then it will store 0 at 0 location, 0, 0 location, 1 at 0, 1 location, 2 at 0, 2 location and 3 at 0, 3 location. Similarly, these are the values. So, whatever our requirement is, with that particular concept, you can assign any value. There is an exercise wherein we have to initialize our two-dimensional array with the I plus j of location, where I is the index of row and j is the index of column. So what we'll do is, we'll take two variables I and j to specify row and column. We will take one 2D array and with 4 number of rows and 3 number of columns. So we'll start 2 loops. This loop is for accessing the row elements and this is for the column elements. And here we can assign I plus j value to its elements correspondingly. So now how can we do some computations? Like if we want to add some matrices, if we have to find out a maximum of a matrix, then how can we do that? Let's say we have a 3 by 4 matrix. That means we have 3 rows and 4 columns and we have these elements in a matrix. Now if we have to find out the maximum value out of all these elements, what is the logic? So how can we do it? So this is the logic. So in that case, what we do is, first of all, we will assign this first element which is at 0, 0 location to the variable named maximum. Right? So after that, we will scan the elements of this matrix one by one, and if we found that any element is greater than that maximum value, that at that time we can assign that value to the maximum variable. So at the end of scanning of the matrix, the biggest element of this matrix will be assigned to the next variable. Similarly, we can find out any number which is present here in the matrix in this form, and in order to add the elements, what we can do is, we have one matrix, another matrix, and we are adding those elements. With the same loop, we are accessing those elements, and matrix 1 same location elements, matrix 2 same location elements. We can add on these 2 elements and assign the value to sum of ij. So in this manner, we can do calculations, we can do computations using two-dimensional array. Thank you very much.